I wanted to make sure we go over some things that you'll be doing online that you need to make sure you can do on paper without the guidance of the computer. One of those is writing down the null and the alternate hypotheses. And what I find with my online students is because the computer gives you the parameters, P, a lot of my online students forget that you have to actually come up knowing that we're testing a proportion. And how do we know that? Well, our variable is the dropout rate for all college students with loans. And there's the 30%. So we know we're dealing with a proportion. You either drop out or you don't. So that's the clue that our parameter is P. So I know on the screen here, all you have to do is click the equal sign, click the not equal sign, or what is this? Suppose that complete dropout rate given the null to test that the dropout rate is not 30%. So I'm going to push not equal to. Again, it makes it a little easier for you. And I'm just going to put the 0.3 in here and the 0.3 in here as well. But you also are responsible for coming up with these P's. So what I would do if I were you is try to look at these questions. I would cover up the screen with a piece of paper. I would cover the null and the alternate up. I would write mine myself and then punch in and match theirs. So just make sure that you're coming up with everything, the null, the alternate, write it down so that you practice it. Let me check my answer as well. Now, the other thing that I wanted to point down is your book is teaching you the one proportion z-test early, and that's cool, but I may ask you to draw these situations, these scenarios, and this is just, remember, this is just the sampling distribution for the parameter P. So if P is 30%, right in the middle here is our 30%, and then we would need the test statistics. So notice here's Z. This is just given to us on this output, so I don't have any calculations. I'm just going to look at the output 1.0911. But notice that that value, that Z-score is right here. That is the test statistic. So when we got our sample, we actually got a p-hat that was above our null hypothesis. Now the question in hypothesis testing is it significantly above enough to say that our hypothesis must be wrong, or is it a common value to have if our null hypothesis, our parameter, it really is 30%. And so let me get a check answer there. Nice job. Yes, thank you. And then the last part is the, it didn't ask me for the p-value. Maybe I want to go back. I want to go back. I want my picture. So I'm going to show you the p-value right here is the area of getting this test statistic or more extreme. Now notice this was a two-tailed test from the alternate hypothesis, and that's why the p-value is not just the area over here, it's also the area over there, together, these two together. So I know that the area over here should be 0.1376, I believe, 0.1376, because to get the whole p-value, you have to take 1.1376 and double it to get that 0.2752. So what I want you to make sure you're understanding also is you're going to need to be interpreting the p-value. So there are three things that I want you to do when you're interpreting the p-value. Let me find them. Okay. So when interpreting a p-value, there's basically three components that you need to understand about a p-value. Number one is the p-value is a probability. It's the chance. Well, what is it the chance of? It's the chance that we get the result from our sample data. So whatever we get from the people we survey, that result or more extreme, where the p-value tells us the chance of getting that, assuming that the null hypothesis is true. Okay, so there's three things. The p-value is a probability or chance. It's the chance that we get the result from our sample data or more extreme, assuming that the null hypothesis is true. So if I go back to my problem here, and I were to interpret the p-value, and you might have to go back and replay this sentence over and over, my p-value would be, there is a 27.52% chance that out of 400 random college students with loans, 130 of them or more drop out. Assuming that the true proportion of dropout rates for all college students with loans is 30%. So I got all three components. That's a long sentence, but I got all three components, and you need to practice this. I don't want to hear you just say the components, the p-value is a probability that we get the results we got, assuming the null is true. I want you to put it in context of the problem. So again, my sentence was, there is a 27.52% chance of getting 130 or more out of 400 randomly selected college students with loans and getting them to drop out. Given that, my true population proportion is 30%. I should say my true population proportion of dropout rates for college students with loans is 30%. So do you hear the difference? I want it specific to the problem. I want to make sure you understand that in this case, a 27.5% chance of happening is pretty common. So that's not enough evidence to say that assuming a 30% dropout rate, it's not enough to say that that's wrong. It must be, must be okay that we've got a 30% dropout rate and nothing too strange happened. So we're going to stay with that null hypothesis, okay? So those are some things that I want to make sure you know. So again, when they set up these problems for you and you're just punching things in, just be very careful. I'm going to try to go to another one. 15. And here's another example. The p-value would be low or high, or who knows. I didn't read this problem yet. But notice how they're basically giving you the answer. You just have to fill these things in. And a lot of you can do this with common sense. But I want you to remember that on the exam, you have to come up with these whole concepts by yourself. You're not going to be prompted with the p-value would be, pick one of these. You need to just be able to come out and say it and interpret the p-value. Let's see this one. I'll try interpreting this for you. A professor creates two versions of a 25-question multiple choice quiz. Each question has 4 choices. One student got a score of 23 out of 25 for a version of the test given to the person sitting next to him. Test given to the person sitting next to him. The professor thinks the student was copying. The student admits that he hadn't studied but was just guessing. He just got lucky. For the professor, the null hypothesis is p equals 0.25 because it's a 4 choices. 1 out of 4 would be your chance of getting it right, where p is the probability that the student chooses the correct answer if just guessing. And the alternative hypothesis is that the student did better than that. Obviously, he did better. So would the p-value for this hypothesis test be high or low? So do you think that the null hypothesis is true? If this student scored 23 out of 25, I believe the p-value would be low. An outcome occurred that would be very surprising, right? If you're just guessing, getting 23 out of 25 is very surprising. If the student were guessing randomly, okay? So if you were guessing randomly, that would be very low. Check my answer. I want to see I'm fantastic. Just good job. But anyway, I might ask you, what's the p-value? What would the p-value represent? And again, oops, I just went. I'll go back. Again, the p-value would be, in this case, we don't know the p-value, so I can't state the exact number, the value of the p-value, but I know that the p-value is the probability of this student scoring 23 out of 25 or better on this test, given that they were just guessing, and the true proportion, if they were just guessing, would be 25%. Okay, so notice I got, if you want to again go back and replay it, notice I did the 3 components of interpreting a p-value. Number 1, it's a probability or chance. Number 2, it has to do with getting the results of our sample data or more extreme. And number 3, assuming that the null is true. So that's what you need to do and force yourself to look at. If you've already done section 8.1, I would try to go back to it and try to create these answers without letting the software guide you too much, because again, it's not going to be on your exam. So good luck, and also go back to each of these and interpret the p-value using those 3 steps that I showed you. Thank you.